So here is another example of the FCFS na algorithm. And assuming that the processes are no longer starting at time 0, so we have specified the arrival time for each. Okay, so we have 4 processes, P1, P2, P3, and P4, where P1 has a burst time of 8, P2, 4, P3, 9, P4, and 5. And they have arrived in this order with a specific na arrival time 0, 1, 2, and 3. Okay, so we can see here that P1 arrived at time 0 and it has a burst time of 8 seconds. So you can see that it got to execute for 8 seconds, right? And it did not wait for any time at all. So it already got its output right there and then. And followed by P2 since it arrived next. Okay, and in this case, P2 has a burst time of 4. So it got completed after at the 12th na time period. Okay, and followed by the P3 since P3 has arrived the 3rd and P3 has a burst time of 9. So it got completed at the 21st na time period. And lastly, P4 got to execute after 21 seconds, in which the time that P1, P2, and P3 have executed. And P4 has a burst time of 5. Okay, so it got completed at the 26th na millisecond. So assuming. Now, what would be the waiting time? For P1, its waiting time is 0 since it did not wait for other processes. For P2, it has to wait for 8 seconds since P1 still has to execute. And then P3 waited for 12 seconds before it got to execute. And P4 waited for 21 seconds before it got to execute. Okay, and to compute for the average waiting time, we simply have to sum this all up and divide by the total number of processes. So in this case, we have 4 na processes. So it is equivalent to 8.75. Now let us compute for the turnaround time. So said another way, it is the completion time. Okay, and to compute for the turnaround time, it is the interval between the time the process has completed minus the time it arrived. So for P1, it got completed at this 8th millisecond minus its arrival time, which is 0. So its turnaround time would be 8. And for P2, it got completed at the 12th millisecond minus the time it arrived. So at the 1st millisecond, so 12 minus 1. Now, for P3, it got completed at the 21st minus 2, in which the time that it arrived. So 21 minus 2, that is 19. So that is the turnaround time for P3. And for P4, it's 26, the time it got completed, minus the time it arrived, which is 3. So 26 minus 3, that is equal to 23. And for computing the average na turnaround time, we simply have to sum this all up divided by the 4, since there are 4 processes. And it is equivalent to 15.25. Okay, so these are the pros and cons of FCFS. So it's one of the simplest, actually by far the simplest na FCFS na CPU scheduling algorithm, I mean. But the downside is that if we have a lot of long processes or processes with long burst times, and it has arrived first, then the short jobs will have to wait until the long ones have done or completed their processing. Okay? Yeah. So for the next video, we will discuss about the round robin.